Hey, this is Mr. Ng going over the Precalculus Chapter 2 test, taken November 4th, 2019. This is version W. Multiple choice, write the equation of the parabola given the vertex 0, 3 and point -1, 5. So you have vertex form of quadratics, which is y equals a times x minus h squared plus k. So always write down the formula, then you do your substitution. The vertex has the letters h and k, so you're just going to substitute those in for h, which is 0, and k, which is 3. I'm going to point out that that negative sign has to be in the formula. The other point, x and y, so x is -1, y is 5, and what you're doing here is you're solving for a. So solve for a is your first thing you need to do. Now I'm just going to simplify using PEMDAS. So -1 minus 0 is -1, and -1 squared is 1. You have the 3 there and then 5. So this is just really 1 times a, or just a. So minus 3, a is equal to 2. I put that back into my formula here. And then you're only going to use your h and your k. So that's 0. K is 3. And then because you have x minus 0, we don't write that, so you just have 2 times x squared, so 2x squared plus 3. So given the vertex and this point, your form in standard form, these are all standard form, the answer is choice D. Question number 2, list the rational zeros of the polynomial function. Do not find the zeros. So basically what you're doing is you're taking the last term, the last number there, which is 6, and then the first term, you're taking the absolute value, so 4. And what you're doing is, this is called the rational roots theorem, and basically what you're going to do is you list out all the factors of 6, so numbers that multiply to be 6, 1 times 6, 2 times 3, 3 times 2 is the same thing there, and then 4, 1 times 4 and 2 times 2. And essentially what you're doing here is these are all the pluses and minuses, and they're a fraction, so you would do something like this. Use my finger. 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. And then we're going to do the 2, so you have 1/2, 2 divided by 2 is 1, 3 divided by 2 is 3/2, and 6 divided by 2 is 3, and then divided by 4. So 1 divided by 4 is 1/4, 2 divided by 4 is 1/2, 3 divided by 4 is 3/4, and 6 divided by 4 is 3/2. And then I crossed off the duplicates, meaning I already have a 1 there, so cross that off. You have 2 1/2 there, and then you have a 3/2, and you have a 3. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to list one that has 8, and that'll be choice D here. And then those would be the numbers you can test, both positive and negative. Question number 3 was free response. Make sure to show all your work and box your answers. Factor completely and graph, and then I told you guys to also label your intercepts. So you're given standard form, f of x equals 5x cubed plus 25x squared plus x plus 5. And you have 4 terms there. So you're going to factor by grouping. Now, it is possible to factor this by a rational roots theorem, but factoring by grouping would be the easiest if it works. So I'm going to take all 4 of those terms and put them into my box here. I kind of did the z. Let's see if I can draw a z here. 5x cubed plus 25x squared plus x plus 5. And then what I'm going to do here is just take out the common factors, or the greatest common factor. So in these 2 terms have 5x squared in common. This one has x, this one has 5, and this one has a 1 in common. So my answer is 5x squared plus 1 times x plus 5. And again, you can always multiply that out, meaning you put those back on the outside, and you can multiply on the inside to get your original. And then to find all my intercepts, they're both x's and y's. So the x-intercepts will be what you set them equal to, y equal to 0, And the y-intercept is when x is equal to 0. So if I plug in 0 there, I get 5. So 0, 5 is going to be a... let's see if I can find a highlighter here. 0, 5 is there in my graph. And then to find my x-intercepts, I'm setting each of these binomials both equal to 0. This one I'm just subtracting 5, so x equals negative 5. And that is right. My graph should have gone through there. It's hard to see, but that says negative 5. 5x squared plus 1 equals 0. You subtract 1. Divide by 5, you have x squared equals negative 1/5. Now, it's not possible to have two reals that multiply to equal a negative number. So, it's going to be imaginary. So, x squared equals negative 1/5. And if I take the square root, I have x equals plus or minus negative 1 times square root of 1/5. And then the square root of negative 1 is I. The square root of 1/5 is really the square root of 1 over the square root of 5. And you can't have a square root here in the denominator, so I multiply by square root of 5, so you get radical 5 over 5. And that orange part goes right there in that box. So your answer would be x equals plus or minus I rad 5 over 5. This is a odd degree polynomial. Easiest one is x to the first, so start down, end up. Leading coefficient is positive. So here my arrows are starting down, ending up, going through a y-intercept of 5, and x-intercept of negative 5. And of course, you could have used your graphing calculator to look at that. And here is how I graded that problem. 3.75 needs to find zeros algebraically. Maybe you just did it rational roots theorem, or just look at your calculator. If you factored it with a graph but no x-intercepts, or maybe you don't have I, give you 3.5. If you just have the binomials or factored only, 5x squared plus 1 and x plus 5, they give you 3 points. And if you just punch into your calculator and just give me a graph, you got 2 points. And then I asked you guys, what are you doing this weekend? If you had fun, safe, and legal, all of them, you got 1 point. And if you got one of those, you got 1 point. On the back side, free response, make sure to show all your working box answers. Write a polynomial of minimum degree, so we don't know what kind of degree it has, in standard form, so no parentheses, with real coefficients whose zeros are 1, with a multiplicity of 2, and 3i. So multiplicity of 2 basically means you have 2 of these, x equals 1 and x equals 1. And 3i has a conjugate. Its conjugate is negative 3i. So if you put each of those into factored or intercept form, what is that? A lot of students couldn't even get that one to start. So it's just the parentheses x minus. Parentheses x minus on each of those. So I have 1, 1, 3i, and negative 3i. And that would simplify to a plus. And you have x minus 1 times x minus 1, and x minus 3i times x plus 3i. So from there, what I'm doing is I'm just going to multiply here in yellow. Binomial times binomial. That's your FOIL. We're going to multiply, then we're going to add. So multiplying first, x squared, negative 1x, negative 1x, positive 1, and I don't know if I skipped that one, negative 1x. And then if you combine like terms, here's I'm putting check marks to show that if I touch it. So there's no like terms, so x squared. These two are like terms, so that's negative 2x plus 1. And that's my answer there. To multiply these in green, and how did I get that as my answer? I'm doing the same thing here. Running on the sides, or the outside of the box, the multiplying. X times x is x squared. X times 3 is 3ix. X times negative 3 is negative 3ix. negative 3 times negative 3i times positive 3i is negative 9i squared. Remember, I squared is equal to negative 1, so it's essentially negative 9 times negative 1, which is positive 9. So these would cancel because these are opposites, right? 3ix, this is positive. This one's negative, so they cancel, and you're left with x squared plus 9. And then now what I need to do is multiply this trinomial times this binomial. So yellow times green is going to be my orange box. Let me show that to you. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 1 is 1x squared. X squared times 9 is 9x squared. 9 times negative 2x is negative 18x, and 9 times 1 is 9. And it'd be x to the 4th, negative 2x cubed. These are like terms, so that's 10x squared, negative 18x, and a positive 9. And here's my answer in descending order. If you had it all correct, but maybe your plus or minuses in the red box above, then I gave you 3.75. Maybe you made a mistake, I gave you 3.5. I gave you 3 points out of 4, pretty generous. If you have just the binomials, which is this one right there, at least you know how to start the problem. And if you had the zeros or the formula, so if you had an intercept form like x minus in the parentheses, or if you did something like this, x equals 1, x equals 1, these are the zeros. 3i, negative 3i, at least I knew you knew it's going to be a quartic function. Question number 6, write the cubic function whose graph is shown below. I want to zoom in here because I thought a lot of students didn't, hopefully it was obvious enough. I'm telling you that here, this is negative 3, 0. This point is negative 1, 0. And 2, 0 is a third one. So you have 1, 2, 3 zeros, so you have a cubic function that we're going to draw there. So you have negative 3, negative 1, and 2. And a common mistake was using this as a 0. It doesn't cross the x-axis. So I'm just going to put each of those, and again, same thing as the previous problem, into intercept or factored form. So negative 3, negative 1, and 2. And the formula starts like x minus. Now, what's the difference between the two problems in 5 or 6? This one, you don't have to solve for a value. This one, you do have to solve for an a value. Put all your information in. So your x is equal to negative 2's for each of those. And your y value is 4. And remember, the formula has a minus sign in there. So the opposite of negative 3 is positive 3. So negative 2 plus 3 is 1. That becomes negative 2 plus 1 is negative 1, and that's negative 4. That becomes a positive 4, so 4 times a is just 4a, divided by 4, a is equal to 1. So if you know a is equal to 1, I didn't really tell you which form to put this problem in, so if you simplify them, meaning you put in the 0, negative 3 here, but you just have an x, so that would be x plus 3, x plus 1, and x minus 2. So this would be our answer in factored form. If you did in standard form, I multiplied these two, and then multiplied by another one here, then you would have gotten x cubed plus 2x squared minus 5x minus 6. So, 3.5 points if you got x cubed plus 2x squared minus 5x minus 6, but no a value. You have to prove what the a value is 1. So no a value. 3 points if all your binomials are correct, just like the previous problem. Maybe something like that. And if you got at least one of those binomials correct, like x minus 2, then I give you 2 points. Last question, number 7. Find all the zeros given 4x cubed minus 3x squared plus 24x minus 18. I think I made a wrong sign there, and then I give you guys some more time to fix that. So again, 4 terms, you can factor by grouping, or you could have used rational roots theorem. Put your 4 terms into the box. And then you're just finding out your greatest common factor. So here, x squared, 6, 4x, and then negative 3. Now this one says find all the zeros, so that basically just means x equals. So you got to solve it. That equals 3/4. Subtract 6. Students struggling here. Subtract 6. X squared equals negative 6. The square root of negative 6, the factors are negative 1 times 6. The square root of negative 1 is I. The 6 stays inside, so your answer is x equals plus or minus I rad 6. I give you 3.5 points if you factor the quadratic incorrectly, meaning you couldn't solve that. 3 points for partial credit, and then 2 points if you just found one of the zeros like 3/4. So a lot of students try to use rational roots theorem. Just want to show you guys what would happen. Then all the factors of 18 are 1 times 18, 2 times 9, and then 3 times 6. 1 times 2 times 4. Now, hopefully I showed you guys in class that you could just put that into your calculator, which I'll use your calculators. 4x cubed minus 3x squared plus 24x minus 18. And that should have been at least your starting point. We already know what the answer is algebraically, 3/4. So you could have done something like second calculate 0, 0 and negative 18, so it's already there. Let's bring it up. To the left of it, to the right means above in this case, and then exact. And then you have 0.75. So if then you're using synthetic division for negative 3, 24, negative 18, I don't have to test all those numbers. I already know what to start with. 3 times 4 is 12. 4 times 1 is 4. So 12 divided by 4 is 3. That equals 0. 0 times 3/4 is 0. Bring down 24. 3 times 24 is 72. 72 divided by 4 is positive 18. And you add those down, you get 0. And then you realize what you're left with. Remember, this started with a cubed, so this would be a constant. That would be an x, 0x, and this would be x squared. And then you're essentially doing the same thing from this problem. You already know that this is x is equal to 3/4, and then 4x squared plus 24 equals 0. Subtract 24. So I'm just trying to show you guys a different way. Divided by 4. And it essentially comes out to be the same problem. Right there. Okay? So if you're using rational roots theorem, not wrong in this problem. There's a faster way, but I wanted to show you, I showed you in class that you could use your calculator. So each of those problems was worth 4 points. So 12 on that side. 10 on the front side, and then extra credit point. So 22 out of 22 points. Good luck.
Math.
Say it again.
Our math.